Hi everyone, my name is Simone and I'm a software engineer from the London office. I've been working on telemetry and infrastructure for different mobile apps at Facebook. Here with me we have Yaniv from the Tel Aviv office and he has been working for a very long time on FB Lite. Together we are here today to talk to you about some of the challenges that we face and how we are building at scale for low-end user experiences. Let's look at our agenda. First, we're going to give you a bit of background, what it means operating at the scale of Facebook. Second, we're going to look at low-end experiences, so devices that might struggle to connect or that might be limited in resources, some of the limits and trade-off of a possible architecture to solve the problem, and eventually our own solution at Facebook, which is called FB Lite. And Yaniv, in the second part of the talk, we talk to you about maintaining the bot afloat, some of the tooling for performance and app health that we built or that we are using to keep everything afloat. At the end, you will have some minutes to ask us any question. Let's get it started. If we look at the Facebook mission, we want to build communities and bring the workloads together. What this means in tech world is that it doesn't matter where you are, you should be able to connect to any of the Facebook systems and be able to share moments and communicate with family, friends, colleagues, anyone on the earth. And this is challenging, right? Because if we look around the world, there are 8 billion people, but they are all distributed all over the places. Asia, the big chunk of it, followed by Africa, and the remaining part split between North, South America, Europe, and remaining part in Australia. Out of these 8 billion, less than half are running on a smartphone. A bit more than half on a phone. So this means that the difference between those two numbers, it's what is called feature phone. All devices, those are very, very limited. If we look at the smartphone population, 72% of that is running on Android, 26% is running on iOS, the remaining 2% on a different operating system. In the Android world, we have a lot of fragmentation, and this has been a problem or a feature, it depends on how you want to see it, on the Android platform since the beginning of the days. I've been working on Android since 2009, and I still remember Gingerbread, Eclair, and other versions. And the ecosystem of Android has been fragmented by nature because people don't want to upgrade or cannot afford to upgrade. Imagine that you were paying for a data plan, you don't want to download half a gigabyte of data, or maybe your device cannot just upgrade to the latest version because it's a very old device. If we move forward, there is also another problem. Even if devices got released in the same year, they might not have the same specification. So if we look at these 3 devices over here, they all got released in 2017 for different prices, some cheaper, some more expensive. But what makes really the difference, considering that the operating system is actually the same, is their specification. So if we look at core, gigabyte of RAM, internal storage, they are different, even for cameras and other features. And here we have a Pixel 2 at the top, a Samsung Galaxy A3, and an InFocus Turbo 5. So if we were to classify these devices just looking at the year of release, we will actually build an experience that is not tuned for that specific device. So Facebook came up with a metric that is called year class that attempts to classify these devices not only based on their operating system or the year of release, but more on the specification of that device. So let's assume that we could classify all these devices on the year where they would have been a top-notch device. Google Pixel would be a 2015, the Galaxy A3 at 2011, and the InFocus at 2012. In this way, we can actually build experiences that are optimized or that are leveraging certain features of Android that might be available only on high-end devices, for example. In case you were wondering or you were waiting for 5G to be rolled out so at least you don't have to care about network latency, I have bad news for you. US is leading the way at 51% of coverage and other countries are following up. So for a few more years, you will still need to wait to have a decent coverage. And back in 2009, in Africa, 3G had a coverage of 60% and 4G of 45%. And this means that it doesn't matter even if we're making progress in the underlying infra, we still need to account for low-end bandwidth and for cases where the connection might be spotty or not reliable. And the list could go on and on, right? Here I put some of the points that I want to chat about, but you could find others by yourself. What if you have limited disk space? And here I'm talking about more the dynamical part of it. Let's say that the user as field is internal storage Like, how can you upgrade your app? You can't, right? Or you should be very careful about the images that you're downloading. Maybe the user is even paying for data, so you want to be careful about not doing heavy prefetches that might not even be consumed. Or they might have a small battery on their device. So it's super important that we save battery for moments that matter to them. If they have to send an SOS or a super more important message, we don't want to be the ones killing the battery of your phone. Upgrades might be slow, and this is for the reason that I just mentioned in a few seconds ago. And there is another important part that is different languages. So your app should be able to account for different locales, different alphabets, and just support a way to share content that might not just be in English. So if we look at the main Facebook app that you might have used yourself or seen some of your friends or family using it, that's designed for the EpiPath. And with the EpiPath here, I mean you have a decent or good device that connects to a good network, and you're just capable of connecting and using our Facebook system. But what do we do in the case that one of these tick boxes is missing? Let's say that I'm hiking in the Alps, I want to send Yaniv an image, and I try to connect with the main Facebook app. That app might not even start, right? Because on 2G, it's very hard to start a very heavy app. So how do we account for these constrained experiences? Let's look at a possible bullet point of must that an architecture should have, and some of the things that might be just wishes or unnecessary features. So ideally, my APK, my binary, should be very small. And there are two reasons for this. There have been researches that have proved that a smaller APK or a small binary is more likely to be installed by a user rather than a big one, because it takes time, right? And it makes kind of sense. So higher conversion rate for smaller APK size. At the same time, upgrading a small binary is faster than upgrading one that is much bigger, even if you diff or if you come up with fancy solutions. It should be using very little data. So imagine I'm hiking, I still give you that example. I don't want to prefetch videos that I'm not going to consume. I just want to send Yaniv a text from the Alps and say, hey, look at this beautiful picture. Ideally, my connection should be reliable. I don't want to spend my time continuously saying, hey, try to connect, retry. I want the app to take care of itself. It should have acceptable performance. I don't care about, the fastest experience. I want just to be able to enjoy that experience. Ideally, if we look at the context of Facebook, I will want most of the core functionalities. So I would like to be able to message, to see different profiles, get some notifications, consume some newsfeed data, and eventually maybe like and comments on other posts. And last but not least, to kind of remark it, multi-language support. That's super important. If we look at some of the trade-off or wishes, the UI could be just good enough, right? If I look at Facebook, there are a lot of nice animation that might not be necessary just if I want to connect. Offlining might be a nice to have, but not the main feature that I'm using that app for. And expensive features like video prefetching, video autoplay, prefetching a lot of images in case the user consumes those are secondary. So, as a native Android engineer that has worked on it for a very long time, I've always pushed for going native 100%. But I wonder if there is something that we can learn from the browser world and maybe come up with a sort of hybrid. So, in browser land, you get HTML pages. Payloads are actually big, and you need a browser to be installed. But what if you could come up with a hybrid where there is a native mobile app that connects somewhere as a custom protocol and eventually tries to be as minimal as possible to satisfy the constraints of before? So let's chat about FB Lite, how we try to solve this problem and how we try to come up with a hybrid that can solve both. If we look at the big box in the center where there is that Lite server, what we did over there was taking the business logic of our app from the client, bringing it to server, cut down on APK size, binary size, the Lite client, come up with a custom protocol, and eventually create a sort of proxy server that speaks with the Facebook world. Different services, authentication, comments, newsfeed, whatever you can think of. What the Lite server is doing, basically, is having business logic, knowing how to render screens on the device, taking care of product code, so you actually write your product code on the server and not on the client, and eventually it's in charge of talking with different services. So if one of these services changes a contract or has a breaking change, we can take care of it on server. And the client doesn't know anything about that stuff. So what if another point I mentioned having a reliable connection with server? What if we could have a persistent connection that has a custom protocol that is very optimized for our use case, which is the Facebook use case, and optimized for it? So we can keep a small binary connecting and have a sort of just minimal app that leverages our server. What are pros and cons of this architecture? And this is actually what we did for FB Lite. We get our simple and light client, so most of the product engineers don't write code on the client. The only case where you will get to client probably is if you want to leverage a feature that hasn't been onboarded yet, maybe Bluetooth or something new coming to the OS, and you need to support that in the protocol. Most of the code lives on the server, so we can optimize it there, we can trace it there, we can actually measure it. We can offer remote language support in Android and iOS apps. Usually you need to bundle languages within the app, right? And in this case, you cannot do everything server side. It's server changes are backward compatible. Product people can actually write products on the server, and they are actually supporting all clients, which is super cool. We are in high control of data usage, so we can decide how many things to send down the client and kind of control how they get sent down. It's easier to implement for different platforms. You just need to implement a sort of tiny client and connect to it. And you can still leverage platform specific. So when I mentioned animations, I didn't say no to those. I said that's a wish. And potentially on Android, you could leverage the Android way of doing animation. On iOS, you could leverage the iOS way to do that, or transitions. The cons of that is that we complicate a bit the architecture. Having a proxy server kind of puts another Lego block in the system, and when you're building things, you need to take care of it. So imagine that you are maintaining the platform end-to-end, or you want to test it, you need to think about end-to-end. So testing, tooling, and telemetry has to be built around that. If you have any protocol change that breaks the protocol, it has to be versioned. Server increases its resource usage, right? Because you're keeping everything in memory or on a disk on a server, and you need to pay for that. And it's way harder to implement offline. Having said this, I'm gonna pass the ball to Yaniv, which is gonna talk to you how we are keeping everything afloat.
Thank you, Simone. Hi everyone, my name is Yaniv Sabo, and I'm a software engineer on the Facebook Lite team in Tel Aviv. Facebook is growing. Every year, we have more employees and more users, and we need to make sure that while new people are working on Facebook Lite, the app continues to be performant on low-end devices. Facebook is also changing. Here on the screenshot on the left, you can see Facebook Lite from a few years ago, and the screenshot on the right shows Facebook Lite today. It's not only the design and UI that's changed, it's also the set of features that we support. For example, today we have stories which didn't exist in the past. While the main Facebook app continues to introduce new features, we want to make sure that Facebook Lite users are not being left behind and that they are still getting all the newest features that Facebook has to offer. So how do we keep Facebook Lite performant on low-end devices? We have a lot of tooling for that. On the client side, we have Android CTrace, which is used for local profiling on the developer device, and we have Profilo, which is used for collecting traces from production using Facebook's library, which is called Profilo and is available, it's open source. We have the APK analyzer, which allows us to look inside the APK and understand what contributes to our APK size. This allows us to both find opportunities to understand how to reduce our APK size, and also to understand when we see a regression in our APK size, what contributed to that regression. We use Redex, which is Facebook's bytecode optimizer, which allows us to reduce the size of our DEX code, our Java compiled code. We also monitor memory usage to make sure that we won't be killed by out-of-memory exceptions or other performance issues like scroll performance. We also use Facebook's mobile lab, which allows us to run Facebook Lite inside a lab and understand whether individual developer changes are causing any performance regressions. The screenshot here on the right is from mobile lab. Like Simone mentioned, Facebook Lite is very server-side oriented, and for that reason, we have a lot of tooling to make sure that new code introduced on the server side does not cause regressions in important Facebook Lite metrics. We have different toolings for server side. We look at the time to interactive metrics, which are similar to the web time to interactive metrics and are measuring the time until the app becomes interactive. We also have media performance metrics, which measure the latency and reliability of loading images and playing videos. We have toolings for server-side tracing. This allows us to know what the server is doing when generating a response to the client, and also allows us to understand when a regression happens in some metric, to understand what changed on the server side. We always make sure to roll out our changes safely and incrementally, and look at performance metrics while we roll out a new change, either in code or in configuration. Let's look at an example metric, time to interactive metric. This is similar to the web side metric, which is also called time to interactive. When the user starts the app, we measure the time until the app becomes interactive to that user. In addition, we also measure the time between when the user presses on a button within the app and until a new screen becomes interactable. We found that this metric is important for our users on low-end devices and on weak networks, and we monitor this metric closely. Every client and server-side changes are monitored for regressions. We look at the metric whenever we roll out a new change, and we try to make sure that there's no regression in this metric. We try to get a signal as early as possible in the development flow, but we also have alerts on every change in production data. So these alerts capture changes not only in latency, but also in number of samples. We want to make sure that there's no issue with the instrumentation itself, so we also look at the number of samples being collected. We look at every one of our performance metrics across a variety of different dimensions. For example, device year class, Android OS version, country, and otherwise. We want to make sure that there's no regression in any specific subset of devices. For example, we want to make sure that there's no one specific Android OS version that is suddenly slower in the time to interactive metric, or any specific country, or otherwise. Like we mentioned earlier, Facebook always introduces new features, and we want to adapt our culture to make sure that Facebook Lite continues to be relevant. We like to look at Facebook Lite as a development platform. Just as we have the Facebook app for iOS and the Facebook app for Android, we also have the Facebook Lite app. And we want to make sure that product teams, when developing new features, are also considering Facebook Lite, and also make sure to develop new features on Facebook Lite as well. We view performance as a core value of Facebook Lite, and one of the key things that we give to our users on low-end devices. This means that new features shouldn't regress key performance metrics on low-end devices. When we see any new feature introducing a regression, we investigate that and we try to resolve it before releasing this new feature to the public. We try to keep our features on the server side as much as possible. This helps us with reducing our APK size and also avoiding to get any performance metrics regressing. We also established a performance bar for our features, and we federate this bar. This means that product teams when they are working on a new feature, they are trying to meet this bar. And if the feature is falling below a performance bar, then we work together to try and get and improve the performance of the new feature. We have a lot of infrastructure to make sure that new features are not introducing big performance regressions. We call this bending the curve because we try to make sure that new features don't consume a lot of resources from the system. For that, we have different examples. We have a centralized prefetching mechanism, which makes sure that all our prefetching is going through one place and allows us to make sure that prefetching itself doesn't cause any regression to other important metrics, and also to make sure that we prefetch efficiently. This, for example, we prefetch screens within the app, or images or videos. We also have a custom binary protocol, which is very packed and allows us to make sure that our network payload continues to stay small. And we have other features within the infra to make sure that the app continues to be performant while new features are being introduced. We want to always be sure that we are still relevant. We need to regularly reevaluate our metrics and goals, and we make sure that we focus on the things that users on low-end devices really care about. This means that we constantly reevaluate our existing metrics, but also that we make sure that we introduce new metrics around our blind spots. And like we mentioned earlier, we try to always catch regressions for any segment of users. So we don't want some set of devices to be left behind just because they are not very common in the world, or not the most common one. We also need to always make sure to consider new platform capabilities that allow us to improve the app, the Facebook Lite experience without hurting performance on low-end devices. For example, in the past, introducing rounded corners was relatively difficult without hurting performance on low-end devices, and today it's much simpler on new Android versions. Thank you.
All right. Looks like even our backup video it got corrupted, so you people must have been talking about something very, very secret if your talk has been sabotaged. Anyway, so Yaniv, we'll figure this out, and we'll upload the videos on Skills Matter on our YouTube channel with you giving a proper talk. But since we still have a few minutes, what are the main highlights that you are going to share with the audience? And if you have the slides, you can actually share your screen. I'm gonna do this live.
Yeah, sure. Whatever you prefer. How do Facebook Lite performance when there are new developers and new features being introduced all the time on the app, and the different actions that we take and the different toolings that we use in the development flow.
And going a bit to the challenges that come with having, so we kind of stop at the point where we said, we're going to have this proxy server in the middle that facilitates some things, but makes other things more difficult. What are some of the difficulties you guys had to overcome to keep this proxy server going?
Yeah, I can take it, or if Simone wants as well. So, yeah, I think it's an interesting question. There are a lot of challenges around maintaining a proxy because our proxy is stateful, and there's a lot of synchronization work that needs to be done across the client and server. A lot of state to maintain throughout. Like Simone mentioned, we have a TCP stream, which we need to maintain throughout the user session. So I think there's a lot of work to sync out the state between the client and server here, and also to maintain like a low transport between the client and server.
And I think to a certain extent that gives you a floor in terms of performance, right? You can never go beyond a certain number, whereas an app without a proxy will be able to be ultimately faster, right? So you're trading off compute on the user's device for latency.
Yeah, in some cases, yes. Yeah.
Now, we had a question, Alison, maybe you can bring it up about, so Simone was saying, oh, I'm walking in the Alps, I want my app to do this and do that. So those sounds actually like things any app should do, not just a Lite app. So
yes, actually, I can take maybe this question. So yeah, actually every app ideally should be light, efficient, use very little data, maybe not use data that users are not consuming, and being, like as efficient with every possible, hardware, network, and anything. At the same time, there are some constraints that might not be able to make that, like all these constraints being satisfied. And at Facebook, we decided to go for an approach where we try to optimize apps based on different users, different experiences, and try to maximize on these areas. At the same time, there are things that you might not actually implement in other apps. Here I'm thinking about a game, right? I wouldn't put everything on server if I want to have the better, smoother experience, because that's going to increase, for example, latency for network, or maybe relying on a network like might actually deteriorate the experience that I have in the game. Then, of course, if it is a peer-to-peer game, that's a different topic. But imagine just a solitaire or a car game that you want to play on your device. You would not pay the cost of your experience to go to network, right?
Yeah. And Yaniv, if you look at kind of where you're going with the Lite app, what are the so like the title of the talk says, you are able to give 2021 experiences on a 2011 phone. Do you think you'll still be able to do the same going forward? Are there new challenges that are coming as the new phones? Because I expect the new phones, the iPhone 13, the gap with the 2011 phones will get bigger and bigger and bigger. So would there come a point where you say, no, we can't keep up anymore?
Yeah, we are trying to improve the user experience as time goes on, and also, yeah, I think even the time, we are trying to see how do we make the app more interactable on the client side without hurting the experience on low-end devices. So we're trying to think about how to sort of enhance the capabilities that the client knows how to handle. Like Simone mentioned, the app is sort of in a browser and in the native app, so we try to support more rich types of scripting, for example, or a more rich set of features to enable more client-side work without hurting performance.
Okay. So I'm really sorry, guys, for the technical difficulties. Like I said, we'll fix it and we'll upload the proper videos on our YouTube channel and on the Skills Matter site. Any last things, takeaways you and the audience to kind of take from this talk?
Yeah, maybe think a bit outside the box. What I mean here is when you're building an app, try to think also about users that might not, follow the happy path, or, like the happy use case where everything is working, everything is connected, and try to account when you're building an app or a system that is kind of working end to end, try to account also for what could go wrong in that system. Because if we look at FB Lite, we are trying to kind of tackle that tail of users that cannot have, like the experience in the happy path. And that's really important if you don't want to lose users using your systems or products.
Any takeaways from your side, Yaniv?
Yeah, I think like Simone mentioned, I think we generally try to. I think a tip would be to, when looking at a new experience being shipped and looking at performance metrics, try to break it down and see how it affects the weaker devices as well, because they can be swallowed in the whole, because there are not a lot of necessarily weak devices, but so we can lose that signal if we look only at top line. But I'd suggest to try and break down things and look at how new features are affecting low-end devices or weaker networks.
All right. Thank you so much, guys. again, you've got a very challenging talk here. So, but also honestly, an interesting one, and one that both of you know it's close to what I care about. Well, thank you for your time. Take care.
Thanks.